Hello everyone, today we are going to study the reverse bias characteristics of PN junction diode. So let us first switch it on. That is on from there, and from here it is to be on. Main supply is on. In reverse bias characteristics, the diode does not conduct, so the magnitude of current remains very low, and that is why we use microampere. So this should be low. The applied voltage has to be high because at low voltages there is no current flowing in the diode, so it should be at 30 volt. So we shall be reading the observation from the lower scale 0 to 30 volt, and here we shall be reading it from 0 to 100 microampere, 20, 40, 60 from this scale. And this is the diode apparatus. Here you can see the diagram. P terminal should be connected to the negative of the battery. N terminal through the ammeter should be connected to the positive of the battery. This is why it is known as reverse bias diode or reverse biasing of the diode. So here P terminal should be connected to the negative, and in the same way we will make the connections on the apparatus. Voltmeter should be connected in parallel, positive of voltmeter to positive of battery, negative of voltmeter to negative of battery. Ammeter in series. Now let us see how. This side 0 to 30 volts, so we shall be using this part of the output DC and this ammeter connections, and from here we will be using voltmeter connections. Now let us start with this. P should be connected to negative of the battery. So this is the P terminal, this is the P terminal, and this is the negative of the battery. This is connected. Then this voltmeter's negative should be connected to negative of battery. So voltmeter's negative, this is voltmeter negative, should be connected to the negative of battery. Connected. This is how it is done. Now N terminal, or let us take positive of voltmeter to positive of battery. So this is the positive of voltmeter connected to positive of the battery. These connections are made. Now voltmeter is connected, P terminal is connected, N terminal to the negative of ammeter. N terminal, this is the N terminal of the diode, should be connected to negative. This is the negative of ammeter. This connection is being made here, this one. And then positive of ammeter should be connected to positive of battery. This is the positive of ammeter, and this is the positive of the battery. This is how all the connections are being made, and we shall be using this knob to increase the voltage, and then we will observe the change in current. So now let us understand and look at the readings. From here I am going to change. Initially when we will be increasing voltage, there will be no current, because in reverse bias characteristic it does not allow the current. You will see here, now we have changed slightly the voltmeter reading and the ammeter reading. You can note like this, there are two divisions, 2 or 3 divisions. So one division is of 0 to 5, it is showing 10 divisions. So 5 divisions, 5 volt is represented by 10 divisions. Therefore one division will represent 0.5 volt, and here there are 3 divisions, so 3 into 0.5, that is 0.15 volt. Similarly here 0 to 20, they are having 10 divisions, so 10 divisions are representing 20 microampere. So one division will represent 2 microampere. There are 2 divisions, so 2 into 2, 4 microamperes. At this voltage 0.15 volt, 2 microampere, and then we shall be increasing it. Voltage is increased, you can see the increment in the current at different values. You will stop the reading and then note it down. Like at 5 volt, this is at 5 volt, and this one is having 8 divisions. So 8 2s are 16 microampere. Then you will be increasing it, noting down the values. At 10 volt, this is 30 microampere, and these readings you have to note down. At a particular voltage there will be huge current, and that would be known as the breakdown voltage of the diode. At 15 volt, you may note down this value. After 40, there are 3 divisions, so 3 2s are 6, means 46 microampere. And then it would be increasing, like here at 50 microampere, this reading you may observe. So at different positions you may note down the value of V and I. At 20 volt, you are having 60 microampere. Now the current is suddenly increased from here. So this voltage would be known as breakdown voltage of the PN junction diode. Yeah, wherever it is increasing. So it is slightly between 20 to 25, near about 22.5 volt. And then you have to plot the graph. You should obtain this kind of graph, V versus I, and when you will join it to the x-axis, you will get the breakdown voltage. So this is how you have to make the characteristics on your answer sheets, and you have to perform in this way. Thank you.